Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, today we're trying to understand what are GMOs.
So for the record, everybody, neither James nor I are scientists, farmers, activists, or anybody else who really has more than just an hour of researcher's information on GMOs. So
An hour.
well, maybe a little bit more for you because you do a lot more research.
Oh, I was thinking on the other side. That's fine. No, it's all good.
So this is just what are they? We're not going to get into the political thing because GMOs are an exceptionally political thing, pretty much since they've been out. So we're just going to lay out the facts, talk about what they are, a little bit of history, and then we'll give our opinions on them a little bit. But we're going to try to stay, I think, as neutral as we can. Is that right, James? You think?
I think that sounds right. Also, to tell you how much I live in a cave or under a rock or something.
You didn't
You're
know
like,
what they
we
were.
should do GMOs, and I'm like, cool, what's that? And then you're like, this is a very political topic, and I'm like, oh, yeah, I guess I can understand that. But yeah, that's pretty sad.
So James, what are
Luke,
GMOs?
GMOs are genetically modified organisms, like a plant, an animal, a microorganism, all that sort of stuff, whose genetic makeup, this is where it gets weird, right, has been modified in a laboratory using genetic engineering, which sounds pretty interesting, or transgenic technology. So this creates combinations of plants or animals or viruses that do not occur in nature or through like traditional crossbreeding of animals.
Yeah, I think that's where I was a little confused initially whenever I thought about this. So like when I thought about like GMOs, I was like, oh, so this is like whenever I take like my strongest plants and I plant them again, and then I breed those with other strong plants or animals and that sort of thing. And apparently, I guess that's more just I was looking at the history, and we've been doing that as a as a humanity and race ever since the beginning of time. Where the example that I saw was the wolves that were passive and agreed with you. You would breed those with other wolves that were passive, and then they ended up turning into
And you
dogs
snuggle
because
them.
because you have to snuggle a wolf.
Because then you get these Yorkies like on my coffee cup, yes.
Which is the furthest thing from a wolf I could ever imagine. But same thing with like fruits and vegetables that you would plant. Like you would take the ones that didn't rot, or the ones that were bigger, and you would plant those seeds. So we've been kind of doing this, but we've only been doing it at like, I'll say the breeding level, where you're just crossbreeding or taking the strongest, where we've never actually edited the DNA up until like recent history. So
Yeah, this is all super interesting. I had confusion about that as well, the crossbreeding versus actually getting into the lab and doing this stuff.
So
one thing I thought was interesting, Luke,
go ahead.
is that there's no scientific consensus on the safety of GMOs at the moment, which I didn't know. I just kind of assumed they were bad for you just because of the very few pieces of news I've ever heard about them. According to some like statement in 2015 by 300 scientists, physicians, scholars, people in the scientific community out there that do stuff with GMOs frequently, it repeated that an like GMO news is like an artificial construct that has been falsely perpetuated. So basically, GMOs are bad is not scientifically proven, which again, just throwing that out there, take it for what you will.
Yep.
There haven't been epidemiological studies done here to investigate potential effects of GMO food on human health. Again, like you said, we've really only recently started doing this big time, so maybe we don't know the long-term effects. So all of that, just throwing it out there for people to think while we're going through this.
I also think the other thing too, that so back in 1982, the FDA, and we'll go through a little bit more of the timeline, but in 1982, the FDA approved GMO products for human insulin to treat diabetes. And there seems to be, if GMOs are used for like medicine, which it happens all the time, they are always doing gene therapies and this thing with insulin. So in the medical side, people don't seem to necessarily care about GMOs because I I don't know why, but it doesn't seem to be as political. But when it comes to food, it does.
Right.
There's a
Right.
whole Monsanto angle that we'll talk about a little bit later. But I think it's because you're consuming it. Like the idea that you're
Sure. That
eating
makes sense.
something that is like not naturally occurring
As opposed to
is,
like injecting it into your body. That's fine.
yeah. I don't know. So
One fun fact for you,
shoot.
Luke. The person who was solely responsible for pushing this through for the insulin for the FDA, Wilford Brimley. Fact.
Really?
No, that is not true. Do not
Because you
do
got
not quote me on
the diabetes.
that. Do not quote me on that.
You get your diabetes supplies sent right to your house. All righty. So what are GMOs made for?
I don't know.
So GMOs are made because essentially, the environment is terrible for growing
It
things,
is.
generally speaking, in the vast majority of the world. So what
Even if you plant crap in Pennsylvania, this
the
ground is terrible.
exactly. So the primary for food, GMOs, is so that the food can be, let's say, drought resistant. Maybe it does well with too much water. Maybe it's bug resistant. Maybe it's fungus resistant. So
Mm-hmm.
the idea is you want to create a crop that can resist the things that typically kill it, destroy it. Like the potato famine is a perfect thing in Ireland. There was this fungus that just basically destroyed the potatoes in Ireland, and Ireland's population
Love
went away.
potatoes.
Back in 2013, they developed a potato that was resistant to this fungus, but Ireland's like, yeah, we're a green, country. We don't want to do GMOs, so it's still kind of up in the air. But the idea is it's going to produce higher yields. The other thing that a GMO could be is a GMO plant might actually be resistant to pesticides or herbicides. So Roundup like Roundup ready crops is a perfect example. I'll talk about that a little bit later.
All the cancer though, so
It's
that.
not good for you. So yeah, so the idea is the crop is a very hardy crop that you engineer it specifically.
Yeah, when I was reading that, it's like, well, that makes perfect sense. Like, why would you not want to do that? Now, I get there's reasons why you would not want to do that. But yeah, it makes perfect sense to me that, hey, if you know of like a strain of something that performs better in certain regions, try and get that gene out of there and put it in other things to make it successful. So
And I think where people where the problem comes in, it's not just taking. So like a perfect example is BT corn. So BT corn is
BT.
corn that they took a certain BT. I forget what the BT stands for. It's some big long.
I have it written somewhere.
Yeah,
Bacillus thuringiensis.
So what this basically resists these particular bugs and worms that basically kill corn. So it's not like taking a corn gene that's healthy and putting it into this corn gene. It's taking something that's not corn, taking this
it's like soil related,
some kind of soil, bacteria, and putting the bacteria into corn, so the corn has this bacteria in it, and then whenever bugs eat it, it kills their digestive system. So basically it's an insecticide that is inside of BT corn, which is, so is it corn anymore? Because it's corn
with something all new altogether. Right?
Yeah. So you can see why there's some confusion here.
That's interesting. Do you like corn?
Not straight up. If you do like that Mexican street corn where they put all the seasonings and cheese and all that stuff on it, then I'm a pretty big corn fan. Or if you turn it into a tortilla, I'm a big corn tortilla fan.
Okay, very good. Before we move on with the history timeline thingy majig that we're going to be doing here, I think it's time to take a break for a word from our sponsor,
Monsanto.
I was going to say the FDA.
Or
but
the FDA.
Fact,
it is neither one of those.
Nobody is sponsoring us, but we do have some shout outs. God, you always worry about the law. First shout out.
Who do we got?
IDO. A second-year civil engineering student from Israel. So I'm not sure if we've had a write-in from Israel before or not. So that's always exciting, right? Has seconded the vote after hearing it on one of our episodes for what is marine engineering. Okay. So maybe we better get on doing that one.
We have to.
Really likes our Nobel Prize episode. loves the series on great inventors. So that's cool because we keep doing those ones because they're easy. I mean, because they're interesting.
Yes.
And even liked the top 10 buildings episode. So I assume he means he liked my part of it and not the tour of Pittsburgh that you provided. But that's fine.
Come on.
If
he ever comes to the U.S. and he's
You're
here
right.
in the U.S., he can come to Pittsburgh and he knows exactly what to see.
That's true. Numero dos, right in. Josiah K. Here's a quote from the email. OMG, I found your podcast on Spotify last week. I love this. James, stop beating yourself up. Gosh, man, you're smart. Accept it. Luke, super good at pulling up info. And love your rants.
Super good at pulling up info. What does that even mean? Can we block people from listening?
Oh, no, I think it's wonderful. We need more listeners like this. Oh, my goodness. I loved it. Well, if any of you have to tell Luke that he's really good at pulling up info and that I'm really smart, man, I would love to get an email from you. That is just wonderful. If you want some amazing stickers, if you want to suggest some topics, if you want to triple down on what is marine engineering, anything like that, go ahead and just email me and only me directly at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, share. We love all the reviews. And as always, you can tell your smart device to play the Unprofessional Engineering Podcast. And just to pick on James, if you're requesting stickers, you will receive them anywhere from 2 days to 2 years from now.
This is accurate. I'm going to throw this out there. We are doing really well on our reviews. We're up over 300 on Apple alone.
It's like 5 stars too, isn't it?
Yeah, we are 5-star average.
Crazy.
I think we're going to be getting a lot more listeners from our biggest competition, Joe Rogan. Nice. So I think we're about to pass him up, especially after his COVID vaccine comments that have recently come out. So if you're listening to Joe Rogan, forget that.
Come on over.
Come on over. We're welcoming you. How about the timeline, Luke? Do you want to talk about this?
Do you want to talk about how they're made quickly?
No, I don't.
Okay, so let's do the timeline. We can just bounce around on the timeline.
Okay. I go back as far as 8,000 BC. Sort of, kind of. And this is more of just a point of
it was what I talked about earlier, too.
Exactly. So back then's when we would be doing crossbreeding of animals, like for selective breeding to make Yorkies, which was the best of all crossbreeding. Thank you.
Exactly.
Breeding plants, making sure that we're getting their desirable traits, stuff like that. But I wanted to be clear that genetic engineering and crossbreeding, not the same thing.
Not the same thing.
Humans have been crossbreeding, like Luke said, forever, for centuries and centuries. But genetic engineering is pretty new, and it's a pretty new practice. So like splicing of genes directly into an organism's DNA, turns out we didn't have that technology 8,000 years ago. So, or 10,000 years ago, I guess. So a little bit different. And then from there, all the way up to 1866 is nothing, as far as I know.
Nothing.
What do you have then? Anything?
So I'm going to put a couple together.
Okay.
So 1866, Gregor Mendel, an Austrian monk, breeds 2 different types of peas and identifies the basic process of genetics. So this is genetics before we really knew what genetics were.
This was like solving genetics, right?
Heck
like,
yeah.
Do you remember this where it was like the yellow pea and the green pea and like breeding them together sort of thing? I vaguely remember it from like 9th grade biology.
Yeah,
but
I do too.
Interesting.
Then all the way to 1922, the first commercially hybrid corn is produced. Again, this is just hybrid. This is just taking 2 different, desirable traits of corn, combining them in one.
Making a corn baby. Yeah.
And then in 1940, plant breeders, they start to use radiation and other chemicals to change the DNA. So basically to
that
mutate
one freaks me out,
organisms. So
honestly.
Yeah, that one's weird. And then probably the most significant one is in 1953. This is basically whenever chemist Rosalind Franklin, he was kind of the beginnings of DNA. So this cat by the name of James, go figure, Watson, and Francis Crick identify the structure of DNA. So the helical coil, like the real popular twisty coil thing you think of DNA, they actually identified what that structure is inside.
How cool is that?
That's a pretty good microscope.
I'm gonna throw this out there. Rosalind Franklin, definitely not a dude. So gonna make sure we fix that
Okay.
one.
I wasn't sure.
um, what was I going to ask? I was going to ask you something, and it was really important, Luke.
Couldn't have been that important.
Okay, moving on.
1973 is
Oh,
when it
I
all
know.
shoot
Crick or Creek? And not his name. The
for
name's
river.
definitely Crick.
It's
Yeah,
Creek.
for the what? Creek?
It's
Okay.
Creek.
Okay.
Yeah. So 1973. So this isn't all that long ago. This is 2 years before my birth.
It's not long ago.
Biochemist, yeah, biochemist. I couldn't say the word bio. Couldn't read the word biochemist. So
Feeling really
biochemist
good about
Herbert
this.
Boyer and Stanley Cohen developed genetically developed genetically engineered first GMO by inserting the DNA of one bacteria into another bacteria. So they actually took two DNAs, spliced them together, and I'm fairly certain that's kind of when the Incredible Hulk happened.
That Bruce
saying.
Banner was like, "What up?" Yeah. So you mentioned 1982, where the insulin project and Wilford Brimley happened. 1992, I skipped a few things in the timeline just because I thought they were boring. FDA policy states that foods from GMO plants must meet the same requirements, including the same safety standards as food derived from traditionally bred plants. I thought that one was interesting because looking back now, that feels like a no-brainer. Like, obviously, they need to meet those same safety requirements. But probably up until then, it was so uncommon that it was like a non-factor. Like, it wasn't something they even had to consider. But this is when things started becoming much more mainstream with GMOs. So I thought that was weird. 94, the first the first GMO produce created through genetic engineering, the tomato, becomes available for sale after the FDA said, "Yep, this is good. It's safe. Breed those tomatoes."
Apparently, it was kind of a failure. I forget what it was called.
Yeah, I heard it wasn't that
There's
good.
a name of it. It wasn't a very good tomato.
Yeah. Also in the 90s, whole bunch of other GMO produce were created, like
corn,
summer squash,
cotton,
corn,
papayas. Yeah.
Papayas, like, are papayas in high demand?
Well,
Is
the papaya issue was there was a fungus. There was a fungus that was killing the papayas in Hawaii, specifically, and they couldn't overcome what was killing them, so they actually genetically engineered this fungus or bacteria resistant papaya.
Did you research this, or do you just know this?
Me and my videos.
Gosh, that's amazing. Good job, Luke.
Yeah.
What do you have next?
So the next thing that starts to happen is the WHO gets involved, and I'm not talking about the cool British rock band. This is the World Health Organization and the Food and Agricultural Organization of the United Nations. They start to develop guidelines and standards that actually define GMO foods. And I think the challenge was the U.S. is not on the list, but there's like somewhere in a number of like 60 countries require foods that are GMO to be labeled as GMO. The United
States not require this.
It's not required.
Stores take
a
it on
lot of them do.
Like a lot of and stuff.
Or a lot of manufacturers do it themselves, but it's not a requirement yet in the United States. So it's kind of crazy. 2015, the FDA approves the first GMO animal for like food, not a plant, and it's a salmon, a genetically engineered salmon.
Yeah, genetically engineered to grow faster than other breeds of salmon, which is rather interesting.
And my guess is that's just to have food supplies, shorter window.
They were called the AquaAdvantage Salmon. But what I thought was interesting and creepy is that this special fishy was made special to not damage the environment. Like, basically, all of them were born female and all of them were born sterile. And this was because if they happened to escape into the wild, they would completely outbreed all other salmon, use up all the food source, blah, blah, blah. Normal salmon would no longer be around. So interesting that they do that. I guess good that they thought of it, but wow, really creepy that it happens, huh?
So they actually take that approach where they're sterile. So there's something called terminator seeds
Oh.
And so there's something called Roundup Ready seeds. So these are
Mm-hmm.
seeds that Monsanto makes.
Mm-hmm.
And these are corn and soybean, all the other, and
Yep.
alfalfa. And these seeds, you plant them one time and their offspring. So imagine a stalk of corn. You can't take one of those corns off of the ear and plant it and grow another ear of corn. It's sterile, and they're called
Oh.
terminator seeds. So what that does is it it kind of eliminates the ability for this to be crossbred and like moved out and just through wind or
Oh
hurricanes or
yeah, but
whatever.
now it's very limited, right? There's like 4 companies in the world that sell these GMO seeds,
Yeah,
and
we'll,
it's
we'll,
getting
we'll talk about
expensive.
all the Monsanto stuff
Okay.
maybe a little bit later on. But the idea is that these genetically modified organisms, they usually make them so they can't reproduce, just to eliminate any unintentional crossbreeding that might happen. So,
Okay. So I see in 2016, Congress passed a law requiring labeling for some foods produced using genetic engineering to
mm-hmm.
use the term bioengineered. Okay. And then in 2019, the FDA completed consultation on the first food from a genome edited plant, which is a bit different. And we can get into that later on. But now it's time for Luke's rant.
Okay, so my rant is going to be all about the ever delicious Cavendish banana.
You and your banana.
So this is how this episode idea started. I started talking about the Cavendish. So if you don't know, the banana that you and I and 99% of the world eat is called a Cavendish banana. The Cavendish banana is named after Sir William Cavendish, the 6th Duke of Devonshire. So this is like
listener.
Yeah, long time listener, really long time. So he basically was a botanist, and he crossbred these bananas to get, because a normal banana is usually sweeter, firmer, and they have enormous seeds in them. Like a wild banana has big hard seeds in it. And like, who wants to eat a banana and have like a huge seed in it? It's disgusting. Yeah. So he created this banana called the Cavendish, named after him. It makes up 99% of all the global exports of bananas in the world. So by far the #1 banana in the world. The problem is, I love bananas. They're disappearing, James. And I think it's a problem because the Cavendish banana is sterile. It can only be cloned. So it's a real manual process for planting, but it produces a super consistent banana. And there's this fungus called TR4 that's killing it. And it just, there's no way that it's going to survive. And it's decimating banana plantations all over the world, in South America and other regions. And I'm a little nervous because I love bananas. Like,
sorry, yeah,
I probably eat at least 1, maybe 2 a day minimum. Probably. I love bananas. They're so good.
Yeah, they're fine.
And this is where, so again, this is more of, it's a rant kind of opinion piece. I think that right now they're working on creating a GMO Cavendish, where they found something that can resist this fungus. They're going to put it into the Cavendish, and then it'll bring back the Cavendish banana back to where it was. Problem solved. But it's a GMO banana now, and is the world ready for the #1 fruit in the world by far is bananas to be yeah, it is by far. Do you want that to be GMO? And
do you like bananas more than all other fruit?
Personally, no, but I get globally because it's really nutritious. It's filling. It's it's good.
You know what? I hate banana flavored candy. I'm putting that out there, like Runts or like the banana popsicles. Oh God, they're bad.
So that's my Cavendish. It's a rant, an homage. Hopefully the Cavendish is still around in 10 or 20 years, but it doesn't look good right now.
Sorry, bananas. Good luck. Luke, how are GMOs even made?
So I'm going to do...
It's a 4-step process?
I'd say it's a 4-step process. It's funny because you can tell whenever like the Google machine produces very consistent like feedback of like results.
The FDA has strong SEO because it certainly shows up fast on the results.
So how are they made? So first of all, you have to identify the trait that you're looking for. So let's say you want your corn to be resistant to this particular worm. So that's the trait you want to be. So you've identified the trait.
You have to find that gene.
You got to find the gene that resist that
Mm-hmm.
worm. So then once you find that thing inside of the thing that resists it, because it's at the gene level, you then have to copy that gene. And I'm assuming it's like a photocopier. I'm not exactly sure how this works.
What were those blue ones? The ones that, oh man.
The blue
Anyways,
ones,
sorry. Go
diazo
ahead.
machines,
Maybe.
ditto machines,
Ditto machines.
ditto
Ah, they
machines.
smell so good.
So then you copy that trait. And once that trait is copied and isolated all by itself, because you don't want like a fungus corn, you want just the resistant piece of this bug to be in the corn, then they insert that into the DNA of corn that propagates, and next thing you know, you grow a plant that has this additional DNA inside of it, and then the corn kernels that come off of it now have that resistance built into it.
Yeah, it's pretty cool
Simple.
stuff. Yeah, oh,
Simple, right?
absolutely, very easy. The entire process of bringing like a GMO plant into my store at Giant Eagle in Monroeville, it takes several years to make this happen.
Oh, yeah.
Probably more than several, but to do the whole science part of it, several. Scientists, though, are working on ways to create new variants of crops and animals using something called genome editing, which is a little bit different. And these techniques can make it easier and faster to make the changes that were previously done with like breeding, which obviously takes like centuries and centuries to
Mm-hmm.
get the results that you want. There's a bunch of genome editing tools. One of the main ones that you hear about is CRISPR, CRISPR. And fun fact, I just saw our friend, close personal friend, Neil deGrasse Tyson,
Yeah, yeah.
talking to some guy about CRISPR. And this
Oh,
some guy was like a Nobel Prize winning dude that developed this, I think. So check out that episode of Star Talk or whatever he was on when they were doing it, but don't leave us. But anyway, scientists can use the newer genome editing tools to make crops more nutritious, just like this drought tolerant, resist disease, all that stuff. But what's interesting is we won't get into this whole the way CRISPR works and the details of it, but basically, it was my understanding that you would take like little bullets of gold or something else and like attach a piece of the DNA that you wanted onto this bullet and shoot it into the thing that you're trying to get it into. And then it gets stuck as the bullet's going through and it just kind of gets absorbed into the thing that you're trying to make better, which is really weird and interesting to
mm-hmm.
me and far outside my knowledge base. But this could be a whole episode on its own. Very interesting stuff, though.
So it says the essence of CRISPR is simple. It's a way of finding specific bits of DNA inside of a cell. That's simple.
It is
After
simple.
that, the next step in CRISPR is gene editing is done to alter a piece of the DNA. I mean, how that's simple, right, James?
I
You
mean,
just
I do this regularly in my backyard.
so I think we have to talk about Monsanto a little bit, and we have to talk about Roundup ready crops. If you didn't have anything else,
No, keep going. I have some fun facts, but I
okay.
want to hear your stuff right
So
now.
so again, at the top of the show, James had mentioned that there's no scientific evidence right now that says GMO food is bad for you, like it causes problems. And I think where a lot of the kind of fights happen and some of the things that are occurring politically is with Monsanto specifically. I'm sure there's some other companies out there that do this, but so what Monsanto is, they are the manufacturers of Roundup. So Roundup kills all vegetation. That's what it's known for. There's also all kinds of class action lawsuits because Roundup causes cancer. It's a carcinogen. There's FDA labeled it. All kinds of bad stuff happening with Roundup. So what Monsanto did was they made these crops that were they're GMOs, and you can spray Roundup on them all day long. So the way a Roundup ready crop goes is you have corn or soybeans or alfalfa, you plant this, and then you spray Roundup on it to kill everything else except for the plant that's Roundup ready and can resist the pesticides that are inside of Roundup. So it's a perfect system, but it creates this dependency on farmers where they can only use Roundup and then they can only buy seeds from Monsanto, and there's this really, in the price of these, and then these are terminator seeds usually, so that means the seeds don't reproduce, so you got to always buy seeds every single year off of Monsanto.
Mm-hmm.
And then there's been all kinds of legal things where like Monsanto seeds get into other people's organic farms and they lose their organic status. So I think there's just a big thing where a big organization like Monsanto has a lot of control. So rather than reducing pesticides, which is what you would hope GMOs would do, they would reduce the need. And I have a couple examples of that. What Monsanto has done is they've increased the use of their product Roundup on crops. So it's a bit of a problem. And I think that's where a lot of the political debate happens. So if you go the opposite direction, there was the eggplants in India is a staple.
I saw that, yeah.
And the thing with the eggplants in India is these farmers were getting sick from using so many pesticides. So rather than making eggplants Roundup ready, they actually just made the eggplants resistant to bugs, and then they could use less pesticides, which that seems to be the direction that you might want to
like
go.
A better choice
with GMOs. So just lots and lots of things going on there with, I think big companies like Monsanto kind of doing what they do, I think is the bigger problem here.
I feel like they need to do this with grass seed. Like, have my grass grow, and then I can just dump poison on it so it kills all the dandelions and clover, especially clover. Ooh. And, my grass keeps going strong. It can use the dead corpses of the dandelions to fertilize itself. Couple of fun facts for you, or do you have more to go?
No, I just wanted to make sure we talked about Roundup Ready and some
perfect.
of that stuff. I think that's something that was really important when we talk about GMOs.
Okay. Fun fact, Luke.
Shoot.
Fun fact. Although GMOs have been around since like 1996, just since then, up to 70% of the food at our grocery store at Giant Eagle contains genetically engineered ingredients, according to the Grocery Manufacturing Association. That's a lot. That is a lot.
And not all of it's labeled.
And not all of it's labeled. It's interesting because it's mostly like corn, okay, well, corn, I get it, but then there's all of the things that corn's used in to make other products, that soy, all of that stuff. Some of the concerns about genetically engineered foods have more legitimacy than others. Like, will eating the food cause health problems? Probably not, according to most studies. However, when it comes to concerns about the consolidation and sustainability, just like what you were talking about, based off of pesticide resistance and things like that, those fears are pretty valid. And that there's actually a union of concerned scientists who reject GMOs altogether because they just see that something bad's going to happen, both to the economy because of it, but also, like you're saying, this corn could get into the organic crops and cause problems as well. Not so good there. Good thing, though, GMOs help protect our environment. So this is an added benefit. GMO technology helps farmers improve on-farm practices to become more environmentally friendly and more sustainable. Whereas this, the use of biotechnology in soybeans, corn, cotton, things like that has decreased soil erosion by 93%. That's crazy to me. And herbicide runoff by 70%. And greenhouse gas emissions by 326 million pounds across the US since the mid 90s. So there's some good things to it as well.
Yeah, one of the ones, and I'll add one more, is so there's this example. So in certain countries where rice is the staple of their food, so rice has no rice. So rice has no basically nutritional value, and what happens is when it's a staple of your diet, if you don't have vitamin A, you can go blind. And young children, if they don't get enough, it causes all kinds of vision problems. So what they did was they developed something called golden rice, and it was rice that was genetically engineered to have this, I don't know what it is, but it's essentially vitamin A, and it's going to stop children from, having blindness, throughout their life, because now they're getting, beta carotene or vitamin A or whatever it happens to be. And there's huge protests against it. And that's one of those where I can see the benefit, and I don't necessarily know if I understand like the flip side. Like, why would you not want that to be a benefit. And I can see both sides. You know, you're eating something that's genetically engineered, but also it's saving the sight of children. So it's definitely a hot topic, James. And I
For
think it's
sure.
going to get hotter
Oh
as
yeah.
time goes
It's
on,
not
and
going away.
it's not going away anytime soon.
I know we're over time, but three quick things. The
Shoot.
gene gun with the golden bullet that I talked about might not be exactly how CRISPR works, but that's originally how this genetic modification was done with these gene
Gotcha.
guns. Number two, they're using goats now to to use the goat's milk that creates a drug in it that is used for unwanted clots during operations and surgeries and childbirth. So the
Okay.
goats themselves are injected with something that, or like have this gene editing going on so that their milk produces this medicine basically.
Interesting.
And then last but not least, there's a current idea to change the DNA of existing like relatives to extinct things. So one example they give is inserting genetic material from mammoths, extinct mammoths, into African elephants. And then those elephants would become closer and closer, having babies and whatnot, to like woolly mammoths of the past.
That's
So
totally Jurassic Park.
maybe we're getting some Jurassic Park stuff going on here. All very interesting, regardless of what side you're on. Anything else, Luke?
That's all I got.
Gosh, this was a good one. I
It was a very
really
good one.
thought it was interesting stuff, especially because clearly I am clueless. If any of you thought this was interesting, if you have some opinions to share, if you want to talk about gene guns or anything else, why don't you email us at unprofessionalengineering@gmail.com? And until next time,
See ya.